let's again talk a little bit about rate orders. And we said a rate order is just a mathematical concept that helps us to describe the relationship between a rate and some concentrations in a mathematical context. So, for example, we said the velocity of a reaction, and let's say we have compound S that is consumed. We said the rate of this reaction would be plus or minus. If it's consumed, loud? It's minus, thank you. Minus K times S, let's say, to the power of 0. What order of reaction is this? What is the rate order of this guy? It's a 0 order because there's a 0 here, yeah? So that would be a 0 order. And instead of S to the power of 0, I can write 1 basically, because everything to the power of 0 is 1. So I can write V equals minus K. Okay? So the rate of this reaction would be a constant. What would happen to the rate, to this guy here, if I was to increase the concentration of S? Let's say S, the concentration of S, instead of S I take 2S. What would happen to the rate? Would anything happen to the rate? No, because the rate, this guy here, is completely independent of S. And if I increase S by a factor of 1,000, still wouldn't happen anything. Because for a 0 order reaction, it's just simply a constant. So in this case, the rate is independent of S. Doesn't matter how big S is. Okay, fine. Let's have a look at another one. Let's have a look at, again, we have this one here. V equals minus K times S to the power of 1. What is that? What is the order? It's a first order reaction, yes. So first order. Absolutely right. What would happen if instead of S, I take 2 times S? What would happen? With the rate? Is V independent of S in this case? Good thinking, but is V independent in this particular case? No. V is dependent on S. So in this case, V depends on S. So if I double S, what would happen to V? It would, well, it would also double, wouldn't it? Yeah? So V would double. If I increase S by factor 3, V would increase also by factor 3. For the time being, let's ignore this minus sign here, yeah? How would this look like if I do a plot? So here I plot my concentration of S. Here I plot my V. The more S I have, the more V I get. Would look like that. Yes? Happy with that? And if we go to the previous example, if we plot that, S, V, well, it doesn't depend on S. How would the line go? What do you reckon? Yeah. How would it go? It would be a horizontal line, exactly. Because V doesn't depend on S. If I add more S, nothing happens. That makes sense? Here's another one. V equals minus K times S square. How would it look like, this graph? And what would happen if I go from S to 2S? How would V change in this case? So all I need to do is really I take this 2S and put that in here. So I have V equals minus K times 2S squared. Yeah? So what's the factor? The factor is 2 to the power of 2. So V would be 4 times the original V. And it would look like Vs. If I plot that, it would look like a quadratic function. Yeah? If it was a third order reaction, it would be, and if I double S, it would be factor 8, 2 to the power of 3. That make sense? If you think about it, probably it does. Right, so that was sort of a bit of foreplay. Now let's have a look at a very, very weird reaction. I'll write this reaction down and you tell me where you have seen this reaction and what it's called. V equals Vmax times S over Km plus S. Who is that? Yes, we all love it. It's the Michaelis Menten equation. Bi 301. Now let's look what this reaction does. What this strange equation does. Let's say we look at the case when S is much, much, much bigger than Km. Okay? If S is much, much bigger than Km, what I can write is Km plus S is roughly the same as so let's say S is 10,000 and Km is 1. So what is Km plus S? It's pretty close to S, isn't it? Because that would be 1 plus 10,000, that would be 10,001. So the 1 is for your birthday. Just ignore that. So it's pretty close to S. So what we can do is we can write our Michaelis Menten equation. We can rewrite this, and we can say V equals V max times S divided by, well, and Km plus S gives me close to S, gives me S. What happens to S? It cancels. So I have V equals V max. Now, if I leave my enzyme concentration all the way constant in all the experiments, I can actually treat V max like a constant. By the way, what is V max? What is V max? What's V max? You've done that. You did it, but you can't remember. What?
I didn't understand it when we did it. It's the truth.
Huh?
Nobody got it. Well, I didn't. And I know that people know.
What? Yeah, that's right. That's right.
What does that mean?
What is V max? What does V max tell you? What? No? No? V max is the rate at which the enzyme can work maximum. This is sort of, imagine you're driving a car, right? And you step full down accelerator. This is how fast the car can go, Vmax. It's the maximum velocity. Does that make sense? Yeah? And of course, the speed of the car depends on the engine. I mean, with my Suzuki Alto, it is on a good day and the wing mirror's in, it's about 60 miles an hour. Right? If I had a Ferrari, boom, and gone. So Vmax is the maximum speed. Maximum speed of the enzyme. And Vmax depends on the enzyme concentration. So Vmax depends on the enzyme concentration. Like the car depends on the motor that's in there. Does that make sense? Yeah? You get it now? Oh, fantastic. So, let's go back to what we said. V equals V max. So if we do our beloved Michaelis Menten plot, and of course you have heard that you under no circumstances ever you are allowed to use a Michaelis Menten plot. Have you heard that? Michaelis Menten plots. So what you would have is V versus the concentration of S. Yeah? Using a Michaelis Menten plot to get the enzyme parameters is like having sex with a condom that has a big hole. Never, ever, ever do that. Completely pointless. Right? Why are you pointing?
Oh, I'm not sorry.
Okay, I was just... Sorry? Sorry if it makes you feel... I'm just trying to point out. Complete no-no. Yeah? Never use a Michaelis Menten plot. Why? Okay, why are you not allowed to use a Michaelis Menten plot? Okay. Here is a typical Michaelis Menten plot. Yeah? Something like that. Can you tell me from this plot where Vmax is? Why not? No. Don't do any fancy mathematical things. Where is Vmax? Vmax is the speed at which the enzyme goes maximum. Aha. Vivian points like that. Yeah? So it must be... Okay, let's see if we find Vmax. Could it be like that? Yeah? So Vmax would be... Vmax. Yep. But it could also be that it still goes on and on and on. What would be Vmax? It would be higher up. Or it could be that it goes like that. Where would be Vmax? Vmax would be... So Vmax is basically, what you would find from this Michaelis Menten plot would be completely random numbers, Vmax. That's why you're not allowed to use a Michaelis Menten plot. That's why you have the linear transformation into, for example, a double reciprocal plot, Lineweaver-Burk plot. Yeah? We are together again? Okay, fantastic. Never use a Michaelis Menten plot. I use one now because we said if the substrate concentration is very, very high, and I abbreviate it like that, then V equals Vmax. Does V depend on the substrate concentration in this case? If you look at the equation, does it depend on the substrate concentration? No. If it doesn't depend on the substrate concentration, what order is it? It's a zero-order reaction, so zero order. So if we plot that, V versus S, zero-order reaction, very high S, we would get a horizontal line. Yeah, makes sense? So that's a zero order here. If S is very, very high. Okay? So far, so good. Now let's have a look at the case, excuse me, where the substrate concentration is much, much smaller than Km. Let's write down our Michaelis Menten equation. V equals Vmax times S divided by Km plus S. What would happen to Km plus S? Km plus S is roughly, so we say this one is now 1 and this one is 10,000. What is it? It would be probably close to Km, roughly Km, yes? 10,000 here and 1 would give us 10,001. So the same argument again. So it's roughly Km. So I can rewrite my Michaelis Menten equation. I can say V equals Vmax times S divided, and instead of Km plus S, I can write Km. Yeah? Makes sense? I can write this in a slightly nicer format. I can write this V equals Vmax over Km times S and I can treat Vmax as a constant and I can treat Km as a constant. And I'll come back to Km, what Km represents in a minute. You know what Km means. You know what Km is? What is Km? Have you done BL 301? Are you still here? Hello, are you awake? Km. What is Km? It is the Michaelis constant, yeah? It's a Michaelis Menten constant, Km. What does it tell you? It's just there. God-given. Hallelujah, we've got a Km. Okay. Anyway, let me just still carry on with that for a moment. So we can treat this as a constant. So we have V equals constant times S to the power of 1. What order is this? It's a first order reaction. Hang on a moment. This is weird. Didn't we just say that if S is very big, we get a 0 order? And now that Klapper guy tells you if S is very small, we end up with a first order reaction. It sort of seems that our Michaelis Menten equation hasn't made up its mind what it wants to be. Sort of in the middle. Let's have a look again at our Michaelis Menten plot. S versus V. We said if S is high, we have a zero order. It's horizontal. If S is very low, we have a first order. So this range here, that's first order. This range here is zero order. What's in between? Yeah, it goes like that. In between is anything. Anything between first and zero order. So the Michaelis Menten equation or reaction has a sort of personality crisis. Doesn't know what it wants to be. First order, when the substrate concentration is very low. Zero order, when the substrate concentration is very high. And anything in between. So sort of almost split personality. And if you do a little bit of maths, which I don't want to subject you to, what you find is that the order of this reaction, order of the Michaelis Menten reaction, is not a straight number. The order of this reaction depends on Km and S. So this is the order of the Michaelis Menten reaction. Km divided by Km plus S. So, if S is very big, then this one is the dominant one. You divide something by something very big. That means it goes close to zero. Or, if S is very, very small, then this means that Km is the dominant one, and you have got two Km's, and it cancels itself out. So it would be 1. So if S is very small, this is a first order reaction. Now, let's go back to the true enzyme stuff. So what you see here, actually, what you see here is that reactions can change the order. And the Michaelis Menten equation is a very almost simple reaction. Looks very, very innocent, but oh boy, does it do things. But let's go back to what these enzyme things tell us. Vmax, we said, is basically what happens when the when the substrate concentration is very, very high. So Vmax tells us how the enzyme behaves when the substrate concentration is extremely high. Yeah? That is what Vmax says. And it depends on the enzyme concentration. It depends on what motor I have in my car. That is what Vmax says. We also just said Vmax over Km, that was our constant that we just used, and we just said there's a constant. This is something that happens when the substrate concentration is very, very small, diddly squats. So Vmax over Km is a parameter that tells us how the enzyme behaves when the substrate concentration is very small. Yeah? And we said, for example, this is your Lineweaver-Burk plot. What do I plot on a Lineweaver-Burk plot? What's on the x-axis? Anyone? Hazard a guess?
1 over S.
1 over s, thank you. What is on the y-axis?
1 over V.
1 over v. I should get, in theory, a straight line. Yeah? Coming back. What is this point here?
Okay.
1 over km? 1 over v max? What else? This point here is, you're absolutely right, 1 over v max. Yeah? So this tells us how the enzyme behaves at very high substrate concentrations, this point. Although it's 1 over, you have to be careful. What is the gradient of this thing?
Is it V max over Km?
Close.
Km over V.
Km over V max. Because in a Lineweaver-Burke plot, everything is sort of standing on its head. Yeah? So this basically tells us how the enzyme behaves at very low substrate concentrations. What have we got here? This point here. What's that? Loud? Very close. It's minus 1 over km. Minus 1 over km. Yeah? Lineweaver-Burke plot is all right. It's not a good plot, but it's okay. You want to have a look at other plots like Eddy-Hofstee plot. Eddy-Hofstee plot is much better for a number of reasons. Anyway, we have Vmax, we have Km over Mac, or rather Vmax over Km. But what the heck is this Km thingy? What does Km tell us? Okay, let's write down our Michaelis Menten equation again. V equals Vmax times S divided by Km plus S. And we can deal with it if S is very big. We can deal with it if S is very small. Now, let's say Km is equal to S. What would happen? Now I can write V equals Vmax times S. And instead of Km, I can say S. Yeah? Happy with that? Or I can also say Vmax times S divided by 2S. Okay? It's not witchcraft. What happens to S? Cancels out. Oops. That's weird. Because what I have now is, if Km equals S, then V equals half of Vmax. You've seen that? Yeah? V equals half of Vmax if our Km is S. What does this actually mean? It tells us the affinity of the enzyme for its substrate. So Km tells us the affinity of the enzyme for the substrate. Huh? How does it do that? Well, if the enzyme has a low Km, so Km is low, it means that I only need a little bit of substrate, only a little bit of substrate is required to achieve half of Vmax. I need just diddly squats. So the enzyme really loves the substrate. Yeah? But if the Km is high, it means I need lots of substrate in order to get the thing going, to reach half of Vmax. Lots of S is required. To reach half of Vmax. Yeah? So in a way, Km tells you a little bit about the, if it was a car, it would tell you about the fuel efficiency. Yeah? How much, in this case, how much does the enzyme like the substrate? That is what Km tells you. And very importantly, Km is completely independent of the enzyme concentration. Independent of enzyme concentration. Enzyme concentration does not come into Km. Km, in fact, is just an accumulation of rate constants. So if I ask you now, what do the three important enzyme parameters actually tell you? Vmax, this is when the reaction goes into zero order mode. Vmax tells me how the enzyme behaves when the substrate concentration is very high. Vmax over Km, that is when the enzyme is in the first order mode. Tells me how the enzyme behaves when the substrate is very low. And Km, the Michaelis constant, tells me how much substrate I need to get half of Vmax. Or in other words, Km tells me about the affinity of the enzyme for the substrate. Km low Km low, this means high affinity. I love the substrate. Km high, I need lots of substrate to get it going, means low affinity. That's why you use these weird and wonderful plots in order to find these three parameters, Km, Vmax, and Vmax over Km. That's why you have done these plots, these things. Does that make sense? Any questions? Come in. No, it's not me. Are you happy with that? Yeah? Does it make it a little bit clearer what you've been doing? Mm-hmm. Mm-hmm. I'm very pleased to hear that. So, I think my time has come to say sayonara. But if you think that I just let you go like that, without saying proper goodbye to you, you are wrong. Because as soon as I go back to my office, I will post the fourth and last exercise in kinetics. On the last day of term, yes. Due in tomorrow.
You're lying.
Yes.
Okay.
I think it is due in on the 1st of May, which is Labor Day. This time you're not going to have any videos on it. So it gives you a sort of a test run for the exam, because that is, what you're going to revise anyway. Yeah? Usual conditions apply. You can submit as often as you like. Best submission will count. Please do it before the deadline. Please do it well in advance before the deadline, because if people submit 10 minutes before the deadline, I can't give you feedback. Yeah? Bear that in mind. So do it as soon as you can. And you have to get at least 70% to show me mastery, and this will be part of the overall kinetics assignment.
How many questions?
Yes. Yes.
How many questions?
I have no idea. I think it is between 10 and 15 questions. Yeah? And of course you can go back to the videos. By the way, if you haven't found it, or if you haven't read the post, you can find my videos and all the lecture recordings on my YouTube channel, PK11 Kent. All the lecture recordings. There are also a lot of videos on enzymes on there. So please have a look. Have a wonderful break. And be good. Don't do anything I wouldn't do. But don't work too hard. Sorry?
We're still doing the thing with the puppies for the exam.
I hope so. Are you excited?
Yes.